On this activity, we're going to talk about water density and water, how water temperature affects how the water moves. I don't tell the kids anything except for don't touch your bucket of water. Oh, and I forgot. The most important thing when you're working with water, the best thing to get are puppy pads. Get a puppy pad, put it underneath the tray, and it absorbs all the water and you can reuse them. So there's my tip for the day. Buy some puppy pads. They're cheap too. So you're going to have a hot rock and a cold rock. I just happen to have a hot rock. Except for I don't tell the kids. I say, I have a hot rock and a cold rock. I'm not telling you which one they are. Let it sit. Don't wiggle your table. Then come around and remember which side of the box you put your hot rocks on, which side you put your cold rocks on. Go around to each kid and say, I'm going to put some food coloring over each rock. So I put it over that one. And I've put it over this one. And then I have the kids observe. This one also has a full lesson plan with it and a full lab sheet with it. Have the kids observe what's happening to that food coloring. Which rock do they think is the warm rock? Which rock do they think is the cool rock? Why? And it's very important. It's great discussion to hear the kids talking about it. And they love watching it. And as you can see, have the kids get on eye level with it. The closer they can get down and look straight across at it, the more interesting it becomes with them. And watch the colors as they travel. And you can see from the top, it looks different too. And after a while, you let it go, and after a while, you'll see that the colors will start to swirl. Talk about that. Where else would we see something where it would be swirling? What could that be causing? Why would this help cause something in water movement? How could this help with our currents? So talk about, where's the water going to get warmer? Where's the water going to get colder? Good discussion to have. Where do we have warmth? Equator. Water is warmer at the equator. Where do we have it cold? At the poles. And remind the kids, we're talking both north and south there. And so therefore, the cold water travels low and the warm water comes on top. But what happens when that warm water is going towards the poles? It's cooling off. So what's going to happen to it? It's going to start to sink. As that cold water is coming south, it's going to rise because, not south, but towards the pole, towards the equator. And so you've got water changing out. So this is a great demonstration to show how warm water and cold water change places and how it helps add to the movement of currents. And as you're talking about the movement of currents, why does water move? Well, first of all, we've already talked about particles, or the molecules of water, or molecules in liquid, and how the particles move faster the warmer they are. So kids should be able to make that inference that the warmer water is moving faster up on top, and it's going to keep mixing. Another thing to talk about with the kids is why also the earth is always moving. It's always spinning. So because the earth is always spinning, I also take my bottle and I'll take this and I'll twirl it around. So what's happening to that water? It goes around in that circle. Well, same thing is happening in the world. Our water is always moving because our earth is always spinning. Usually the question will come up, what if the earth quit spinning then? Well, great discussion to have with the kids, but not a pleasant thought to think about either. So as you can see, it is mixing a little bit more, and I'm going to show you here how it's mixed more. The kids are intrigued with it, and this is a really nice activity because they say really, very excited and a lot of times somewhat quiet because they're actually concentrating and watching it.